Just going. Okay, parametric equations. So parametric, oh my gosh, stop. Parametric functions are just another type of functions. I'm going to show you how to find them, how to define them, and then we'll move on after this. It's a pretty easy concept. It looks hard, it sounds hard, but it's really pretty easy. All right, so we will say that the parametric equation is defined by, I'm going to get this one straight from your book. We have two equations. We have an x equals, and we have a y equals. Together, these make up our parametric function. Okay? So what we want to do is we'll do several things with this. The first thing we'll do is we'll define it for some. We'll say that this is defined for all points, but the first thing I want you to do is tell me what points, and when I say points, I'm talking about coordinates. So I'm talking about an x and a y. What points are determined, come on, ooh, by t equals -3, -2, -1, 0, 1, 2, and 3.
What?
All right, so let's think about it for just a minute. The only thing this is doing is it's giving me an equation to find the x coordinate. It's giving me an equation to find the y coordinate. Okay? So you're going to plug these t values in to find the x and the y. I think it's probably easiest if we do a chart. So we'll say t I'll have to go down a little bit further. Come on. And 3. And so what we'll want to do is we'll want to find out what is x for these values. And we have a little formula that tells us, right? T plus 1. How do we find y? Come on. Mm-hmm. And so when we put these together, we'll have our set of coordinates. Give you a second to catch up to me. Let's plug and chug, because that's all this is really, is plugging and chugging. When t is -3, what's the value of x? Mm-hmm. All you did was plug it in for the t. What's the value of y? -3 squared would be 9. And then -6, which would give you what? 3. What are the coordinates when t is -3? Come on, y'all.
-3.
Thank you. How about -2? What's the x value when t is -2? How about y? Oh, I'm putting in the wrong value here. Oh, no. So, yes, you put this value in for t. So y is -2 squared plus 2 times -2. So it's 0. So what are the coordinates there? -1, 0. This is pretty easy, right? All right. How about -1? What is x? Mm-hmm. What is y? Yeah? No, only the first one squared. T squared plus 2t. What do you get for y? Come on, y'all. What's 1 plus -2? Oh, I'm sorry, I didn't hear. What's the coordinates? Close. All right, and so now when t is 0, what is x? What is y? Plug 0 in for the t's. 0. So I have 1, 0. Do I need to keep going? Y'all see how to do that? Pretty easy, right? All right. So that's how we find the points. All right. We can also find an equation defined by these parametric relations. And here's how we do that. Finding an equation. All right, so we had these two equations. We had x equals t plus 1, and we had y equals t squared plus 2t. This is where it gets a little bit harder. So what you want to do, your goal is to get rid of the t's. Okay, one equation with no t's. So here's what you have to do. Solve one equation, generally the x one, for t. Well, if you solve that first equation for t, what does it look like? What does t equal? 1. No. Solve this for t. Get t by itself. X minus 1. So just subtract 1 from both sides, right? Now what you're going to do is you're going to take that value for t and you're going to plug it in the other equation. So my goal is to get rid of all the t's. So if I solve one of them for t, okay, and then I'm going to replace all the t's in the second equation with x minus 1. It's kind of like a system of equations. It's exactly like a system of equations, actually. Whenever you did substitution, that's the same thing we're doing. So here, y equals, it's not t, it's going to be x minus 1 squared plus 2 x minus 1. Looks a little like composition, doesn't it? Mm-hmm. So I want to expand this out. I can't distribute that exponent. What do I have to do? FOIL, that's exactly right. So I have x minus 1, x minus 1. I can distribute that. 2x minus 1. X squared.
And then 2x minus 2.
Yep. That's what I had. I'm just kidding. You're right. And then just get your like terms together. Come on, pen. X squared, let's see, negative 1 is negative 2, plus 2, those are gone. Yeah. And then 1 and negative 2 would be minus 1. Now, I know some of you are still writing this fine. What does this look like, though, when you graph it? It's a quadratic. Looks like a what? A parabola. This parametric relation looks like a parabola when it's graphed, okay? We're not going to get into the calculator just yet. Your calculator will graph in parametric mode, and you can put the x and the y in, and it will graph the parabola for you. But we'll wait to get to that. Do y'all have any questions?